Hello friends, this is Coach Veer welcoming back you on my YouTube channel Coach Veer, and in this video we are going to take up this problem which says if this shared addition is equals to this a root 7 plus b root 5 plus c root 3 by 2, we have to find the value of a plus b plus c where a, b, c are some integers. Start solving this, but before, a request to you all, if you have not subscribed my channel and you really like this content, please do so. Subscribe my channel and put a like if you really like this. Thank you friends for subscribing my channel. Let's start the solution. So what we have to do here is taking the left side. You think that root 15 we can write as 3 times 5, right? That is 15. And 35 can be written as 5 times 7. Right, we can write them inside the roots itself because there is a common root. 7 can be written as root 7 times root 3, and 5 can be written as root 5 plus times root 5. Correct. Now in the denominator we see there is a root 3, but there are 2 root 5, so let's write them separately so that you understand there are 4 terms. Now in the numerator, if you think little closely, that these two have something common, yes, and these two also have something common. So let's take out the common thing, which is root 5, and root 3 plus root 5 is left, so root 3 plus root 5. And in here you see there is a common content which is root 7. So what is left? Root 3 plus root 5 or root 5 plus root 3, anything you can write. In the denominator we write things the way it is because something it resembles to the numerator part, right? Now you see there are 2 things and both of them are common. This one is common and this one is common. So we write them separately as root 3 plus root 5 and this part as root 5 plus root 7. Now in the denominator also we got root 3 plus root 5 plus root 5 plus 7, and it was equals to this thing, right, this x. So if this is equals to x, then we can say 1 by x is equals, means just flipping the other side also and this side also, we can write root 3 plus root 5 divided by this whole stuff, which was root 3 plus root 5 times root 5 plus root 7, and this root 5 plus root 7, it is also being divided by this whole thing which was in the numerator, right? Root 3 plus root 5 times root 5 plus 7. Why I am doing so? Because this thing getting cancelled with this and just remaining 1 here. Same happens from this also, it cancel out and 1 remains. That's the reason I am flipping it. Or if you don't want to flip the other side, you can bring that thing in the denominator of this part also. That is also correct. So now we got this and we got 2 things, and it looks like a very easy question to you. I think you have solved this type of questions earlier also, like rationalization thing. You remember we do multiply with root 3 minus root 5 to solve this part and this part also, but let me do it some way around so that you do not have a problem of negative, right? So that's what I am going to do. I am just writing it in such a manner so that you don't have to have the issue of writing that negative thing. So let me write it as root 7 plus root 5 and this part as with a little bit of gap so that we can rationalize 1 over root 3 plus root 5 plus root 3. When we do that and we rationalize this stuff, like multiplying the negative or conjugate of this, so root 5 minus, you are learning new words with me, conjugate, right? This root 7 minus root 5. If you really know what conjugate is, please comment in the comment section. root 5, and this is 1 by x. Now you know the numerator remains root 7 minus root 5, and this denominator just becomes 7 minus 5, and this part plus root 5 minus root 3, and it becomes 5 minus 3. So we all know 7 minus 5 is also 2, 5 minus 3 is also 2, so both are having the denominator of 2, right? So we can write the denominator as 2 for both of them. But that's not it. If we apply this part here itself, then there is a issue. We have to do something so that it keeps on moving, like root 7 minus root 5 plus root 5 minus root 3. You understand, this gives you 2, this gives you 2, so I have a common base 2, and these are the numerator part of it, and it is equals to 1 by x. Now if you cancel out this 5, you are just left with root 7 minus root 3 over 2 is equals to 1 by x. X is equals to 2 over root 7 minus root 3, but we want this part to be in numerator, so we again rationalize something like multiplying it with a positive part. And you know, when we cancel out this is a different shard, not the one we have already done. So this is what we get, and in the denominator we get 7 minus 3, because a minus b, a plus b formula I am applying. So 7 minus 3 is just 4, so you will get 2 root 7 plus root 3 divided by 4, and when we cancel out this we get root 7 plus root 3 by 2. So that's what our x is, root 7 plus root 3 by 2, and it resembles to this thing, right, the x. So a is just 1 and b is 0, c is just 1, so a plus b plus c is going to be 2, because a is 1, b is 0, and c is 1. Hope you enjoyed it and you understand it. If not, you can just rewind the problem and check my solution again. Comment if you understand this or not, any requests or anything you want to amend in this video. Thank you for watching this. See you in my next video. Till then, bye bye.